Hi, welcome back. Today we are going to see about the intermittent periodic duty with starting as well as starting and breaking. That is S4 and S5 duties. So the intermittent periodic duty with starting is denoted by S4 duty. So in this intermediate periodic duty, so what is intermediate periodic duty? Starting, rest. That is operating, rest. Operating, rest. It will be continuously, simultaneously coming. So here, so intermediate periodic duty, operating, rest. Only operating, rest is there. Operating and rest is there. But what about the starting? Here the starting is included in this duty. So here the period of starting, operation, the operation is under a constant load. After that there will be rest. So intermediate periodic duty, it contains only operating, rest. But here starting, operating and then rest. Starting, operating, rest. Okay. So the example is metal cutting and drilling tool drives, etc. So you can see here. So the D, it represents the starting, N, it represents the operating, R is represent the rest. So starting, operating, rest. Okay. So the duty cycle is calculated by operating time divided by rest time. Operating time divided by rest time. Here the starting is nothing but D. So here the starting plus operating, D plus N divided by N, R is nothing but N duty cycle. This is the formula to calculate the duty cycle. So the duty cycle is nothing but the total duration of on time divided by the total duration of rest time. So the rest is R and the starting and the on time is starting as well as operating. Okay. And so during this starting, just we can see the load as well as losses. During the starting, the losses is high. Under normal operation, it comes to some rated value. Once rest, the losses is 0. So during the starting, the losses is increases to the maximum value, and during the operation, the sum was the electrical losses gets decreases. Why the losses and the temperature is always high during the starting while compared to the operating? The main reason, so at the time of starting, the machine is drawn more than 5 to 6 times of its rated current. The rated current is 10 amps. At initially during the starting, it may be 50 to 60 amps it will be drawn by the motor. So that because of the consumption, because it drawn more current from the source, the electric losses as well as the temperature goes to the highest value. That is the maximum temperature. Once within a fraction of a second, once it reaches the rated speed of the machine, again it comes to the ordinary operating condition. So the losses as well as temperature, it goes slowly. Once the machine is turned off, again the machine gets cooled down. And the fifth duty is nothing but intermediate periodic duty with the starting and as well as breaking. So here the intermediate periodic duty, it contains operating, rest. And here the intermediate periodic duty will contain start, operate, break and then rest. Okay, just for example, and two-wheeler. First we have to start and we have to operate and we have to apply the brake and we can turn off. So the period of starting, operating, braking and rest. So here the operation and rest period is too short. So here the braking is done by the electrical braking, but not in mechanical braking. Okay. So the examples are the millet, mill drives, mine host, etc. So here, so D represent the starting, N represent the operating, F represent is nothing but braking, R represent rest. So here DNR is similar to the intermittent periodic duty with starting except the braking. While applying the braking, the amount of kinetic energy which is stored in the electrical drive, it will be dissipated as a heat. That is nothing but an waste. That is nothing but an waste. So that it goes to the negative region. It goes to the negative region. So during this braking, the huge amount of power is gets lost. Huge amount of power is gets lost. So during the braking, huge amount of heat will be dissipated, so that the temperature is also gets increases. So the duty cycle is calculated divided by, so on time divided by half time. Half time is nothing but rest, and on time is nothing but starting, operating plus what about the braking? So it will be an duty cycle. So this is an assessment. Is braking is applicable? Is braking is applicable in ceiling fan? So it is able to apply the braking in a ceiling fan. So put your answer in the comment section. And these are the few textbooks for this topic. Thank you.